Hi, folks. Thanks for being here today. I hope you saw that we're starting a new chapter on complex numbers. So it's going to be really important that you understand what a complex number is. You just should have watched a video on that. But before we talk about when we use complex numbers, first we're going to talk about what are complex numbers. You're going to want to make sure that you have your notebook out, and we're going to talk about some information. And what I'd like you to do is just title your paper, um, I, let's see, I can perform arithmetic operations with complex numbers. You also at this point should have the foldable. Unfortunately, I have the foldable on the side, but this is what you should have. And it may not make a lot of sense right now, this foldable, but eventually it will. So we're going to use this foldable a lot today, and then we're going to also write some information in our notebook. Okay? So let's go back to what I is. Just some information on what we're going to do this chapter. You're welcome to write this down or just keep it so that you know. We're going to talk about simplifying. We're going to talk about multiplying, conjugates, patterns with I, and graphing on the complex plane. Just so you know, today we are going to specifically talk about the following things. We're going to talk about simplifying and multiplying. We're not going to talk about complex or conjugates. We're going to talk about patterns with I, and it's really important you know that. Okay? Later on, we're going to talk about finding roots, writing equations from roots, and then sketching graphs. And eventually you'll understand in this learning target right here, this AA7B1, why we need complex numbers. But right now you're just going to learn about a new number system. Okay, so let's talk about imaginary numbers. I really like that video, and especially when they kind of like pull up the quadratic. But complex numbers arose as a way to solve cubic equations by some important people, Cardinal and Tartaglia, I think is how you say his name, in the 16th century. And in 17th century, Descartes decided to call them imaginary numbers, and Euler decided to call the square root of -1 is I. And that's what you need to know. I is the square root of -1. If I was to write something in my notes, it would be this, okay? This allows us to solve square roots of negative numbers because now we can take out that I, and that's so important. In 1806, Argonne developed a way to represent real and imaginary numbers on a diagram. As you go on in math, or if you go in other kind of STEM-related fields, we do use I quite a bit. Okay, so let's take out that foldable and let's put some information on it. First off, when you look at your foldable, I want you to look at this right here, the imaginary unit of I. It's already written down here, okay? But what's really important for you to understand is some patterns of I. So let's talk about that first, okay? When we talk about patterns of I, and I'm going to click over to my other screen. Actually, you know what? Let's go back a step here. Imaginary numbers solve the equation x squared equals -1, so I squared is -1. Imaginary numbers belong to their own number set and are not positive, negative, or zero, and the sum of a real and imaginary number is called a complex number. I really want you to make sure that you put this information in your notes, okay? And it's written in this form a plus bi. Today we're going to talk about how we kind of put imaginary numbers together, and with real numbers, we're going to add and subtract with complex numbers. So when I have you give me answers today, I should see a plus bi, okay? And so when I say a plus bi, a is your real part, and then bi is your imaginary number, and this is all called a complex number. Okay, so let's take that foldable back out and let's talk about a couple of things with it. Okay, so right here it says on the side here, I know it's hard to see, but it says a complex number is a number that can be written in the form of a plus bi, where a is the real and b is the imaginary. So that's kind of circled. I might star that. But let's talk first about adding and subtracting and multiplying and dividing. Those are your general operations for your complex numbers. And then we'll talk about patterns of I, and then we'll end today talking about how you take the square root of a negative number. Okay, so when we're adding and subtracting complex numbers, we combine like terms. We add or subtract the real parts. I would, if this was me, underline that part in my foldable, okay? And we add or subtract the imaginary parts. For instance, right here, if I want to simplify 2 plus 5i minus 3 minus 2i, I would first simplify 2 and 3. Well, 2 minus 3 is negative 1. And then I would add 5 and negative 2. Actually subtract here. So it's 5 minus a negative 2i. So my end result, and you can write this yourself, when I write my end result, I would have 2 minus 3 is negative 1, and then 5 minus 2i, minus a negative turns to a positive. And so then I write plus 7i. Okay? That's my answer there. And if that was me, I would just kind of put that right there. Notice I added my, or in this case, subtracted my real, and then I also went together with my imaginary. And so I got negative 1 plus 7i. Okay, so that's how we're going to add or subtract. Let's talk about multiplying, okay? And this is where when we start multiplying, we need to start talking about patterns of i's, okay? Because we're going to get some i's squared, some I cubes. What's really interesting about I is that it has a cyclical pattern, and so it repeats every 4. So when I have I to the first power, and I'm going to kind of write this, but hopefully you'll see it and put it the other way, I to the first power is just I. I to the second power is the square root of negative 1 times the square root of negative 1, and so that gives you negative 1. And so when you have I to the second power, well, that's important, right? Because what you'll end up having, sorry folks, I'm grabbing my other paper here, is you'll have I squared is equal to negative 1. So right here I would write equals negative 1. Okay, I cubed is negative I. And then I to the fourth, well, that's I squared and I squared, so negative 1 times negative 1 is 1. Oops, I didn't mean to zoom that in, so let me just, and there we go. Okay, so I to the fourth is negative 1, okay? Or is positive 1. So let's remind ourselves again those patterns. We have I is just, I to the first is I squared is negative 1. I to the cubed is negative I. And then I to the fourth is 1. Well, what happens is this pattern repeats itself all over again. So if I have I to the fifth, it's I. I to the sixth is negative 1. I to the seventh is negative I, and I to the eighth, again, is 1. So it repeats every fourth one, okay? We'll talk about this more, but right now, I really think you just need to know this I squared, and then hopefully you'll see a pattern with the i's, okay? Okay, so let's keep moving on. Now that we know this about the pattern of i's, let's talk about multiplying complex conjugates. So right here in this first one, I have negative 10i times 2i. When we're multiplying with our complex conjugates, we literally are just going to do what we've done before. We'll multiply our numbers. So negative 10 times 2 is negative 20. So I have negative 20 for that one right there. And I'm going to kind of write it like this. And then I times I is I squared. Well, didn't we just got done talking about how I squared is the same as negative 1? You need to change that. Okay, so now we have negative 20 times negative 1, which gives us 20. Okay, so that answer there is 20. So now you know those patterns of i's, you need to make sure you use those. Okay? Okay, let's look at this next one right here. And actually, you know, you are welcome to kind of cross this one off. We're not going to do this one. But this one right here, we are going to use a box situation here, like we've been doing before. Or we can use FOIL. So what I'm saying is we're going to do 2 times 3, which is 6. Okay, and then I'm going to do 2 times negative 5i, which is minus 10i. Okay, then I'm going to do 3i times 3, which is 9i. And then I'm going to do 3 times negative 15i, or 3i times negative 5i, which is minus 15i squared. Well, wait a second. Doesn't that just become positive 15? Because I squared is negative 1, and that's a negative. Two negatives make a positive. So now I have 6 plus 15, which is 21. Notice I'm writing that first, I'm combining those, and then I'm combining my negative 10i and my 9i, which is minus 1i. Okay? I put my real, and then I put my imaginary. And that's what you're going to do today. You could have also done the box method, but I think your FOIL is going to be your best bet. Okay? Okay, let's see what else I have for you. Just so right here, there's some more operations. If you want to take a moment and just stop the video right now and just kind of practice a couple of these, they'll be on the PowerPoint too if you want to look at them, but those are some great ones. Okay, now that you've kind of looked at those, there's also writing them in A plus BI, patterns of I. If this was me, I might kind of put this right here just as a reminder in my notes. So that might also just be a good thing to put in your notebook. So let's stop the movie here real quick. Okay, now that you're back, okay, now you're going to do some classwork for me, okay? One thing I didn't show you on here was how to change square roots take the square roots of negative numbers, okay? So I do want to show you just that really quick right here. If I have something like the square root of negative 4, up until now, I wouldn't be able to do anything for that, right? But now I know that that's a negative 1, and so I can rewrite it like this. I square root 4, and then I'm going to take the square root of 4. I'm only going to have a positive number here, the 2, and that's only because right now I'm just asking you to take the square root. I'm not talking about like an x squared, which has 2 answers. If you're confused on that, remember back to our parent graphs of the square roots. There's only that positive one. But the square root of 4 is 2, so this answer is going to be 2i. Okay? If you're asked to take the square root of a number that's not a perfect square, say like negative 15, what I'd really like you to do is to practice just keeping that under the square root. And I'd like you just to write it like this. I square root 15. And the reason I want you to keep 15 underneath there, because it's not a perfect square, and we're going to talk this chapter about doing things with non-perfect squares. Okay, so what I'd like you to do right now is I would like you to take a moment and get back together with your row partners and work on the classwork. Please do not put this into write on this piece of paper. Instead, please work on this in your notebook. I'll be checking this along with grading your evidence tracker when I see you on Monday. There will be an exit ticket at the end on Canvas. Okay, thanks and have a good day.